Hey, what's up guys, welcome back to my YouTube channel, and today we are going to start TensorFlow. So why would you want to use TensorFlow? The TensorFlow gives us a scalable multi-platform programming interface for implementing and running our machine learning algorithms. While there are several other frameworks available to us, but TensorFlow is by far the most advanced one and the one most easiest to use. Okay, so a little bit about TensorFlow. TensorFlow was first released in 2015, I think, and the first stable version of TensorFlow was released in 2017 called TensorFlow 1.0. So TensorFlow is maintained by Google, and a large team of software engineers is continuously working to improve it. But also TensorFlow is available as an open source. So there is a large community of open source developers that are continuously trying to improve TensorFlow. So TensorFlow can work with both CPUs and GPUs. However, its greatest potential can be achieved using a GPU or a TPU. So TensorFlow supports CUDA enabled GPUs officially, but it also supports OpenCL enabled devices as well, but that one is experimental. Okay, so let's get started. So first let us take a look at how we can install TensorFlow. So there are several ways that you can install TensorFlow. For example, if you are more advanced user and know what you are doing, you can use the pip installation. But in case you are just a beginner and don't know much about environments, so I'm going to show you an easy way as well. So let's get started. So you can open up your command prompt and type pip install TensorFlow. So if you want to install the CPU version, this should be fine, but if you want to install GPU version, you can write TensorFlow then dash then GPU. So this should install TensorFlow on your systems, but you might have some problems with the CUDA installations on your PC, and so if you are not an advanced user, so you might want to use a different way. So I'm going to show you two ways that you can use TensorFlow if you are not an advanced user. So let's take a look at how we can do that. So the first one would be you can go to Google Colab. So if you go to Google search and search for Google Colab and click on Google Colab. After that you will be directed to this page, and over here you can type out the name of your notebook that you want to search for, or you can just create a new one. So I'm going to create a new notebook. So okay, so once it opens, you can type out import TensorFlow as TF, and if you press shift plus enter, this should run the command. Okay, so if this line didn't show any errors, that means that your TensorFlow is working. But if you still want to check, what you can do is you can type out tf dot underscore underscore version underscore underscore, and if you run this, this will return you the version of TensorFlow that you are running. So this is how you can use TensorFlow on a cloud computing platform provided by Google. Now I'm going to show you if you wanted to use it on your PC. So I'm going to search for anaconda TensorFlow. So if you go to the first link, so you can use one of these commands to install TensorFlow, but this is going to be the CPU version. But if you have a GPU on your PC, what you can do is you can type out GPU after TensorFlow, and if you go to anaconda.org again, and this time for TensorFlow GPU. So if you want to install GPU version, what you can do is you can copy this and paste it into your command prompt, and if you run this, this will install TensorFlow GPU on your PC, and you won't run into any problems because this one is managed by Conda, so it will automatically install the CUDA version that is compatible with your system. So this is the easiest way, I think, for beginners. And so since I already have a TensorFlow installed on my PC, so I'm not going to install it again. So I'm going to close this, and I'm going to open up a Jupyter notebook. Okay, so in your notebook you can type import TensorFlow as TF. So now this might take some time depending upon your system, and you have to wait until it imports. Okay, so now if you wanted to check which version of TensorFlow that you are running, you can type TensorFlow dot underscore underscore version, just like we did in the Google Colab. So if you run this command, this will return you the TensorFlow that you are using. I'm using 2.1.0. So next, there are some commands that might be useful once you are really advanced in TensorFlow and you might want to change some stuff with your system. So I'm going to show those commands to you right now. So the first one is if you wanted to check if your TensorFlow is installed with CUDA or not, what you can do is you can say tf.test.is built with CUDA. So if you run this command and if it returns true, that means you have a version of CUDA installed on your PC with the TensorFlow installation. So next we are going to check if our TensorFlow has a GPU support or not. So I'm going to say tf.test.is built with GPU support. So if it returns true, that means your system is built in with a GPU support for your TensorFlow. Okay, so now if you wanted to know the name of your GPU device, what you can do is you can type tf.test.gpu device name. So if you run this code, it will return you the name of the GPU device that you are using. So this is the name of the GPU device that I'm using, and by default your GPU will be set to 0. But if you have more than one GPUs, you can change this setting to any other GPU. So let me show you how you can check if you have more than one GPUs or not. So you can get a list of all the physical devices that you have on your system. So to get that list, what you can do is you can type tf.config.experimental.list physical devices. So now if you run this, it will list out all the physical devices that you have on your system. Since I only have a single GPU, it is only showing a single GPU in this list, but you might have more than one GPUs, but you will only have one CPU unless you are working on a platform like Google Colab. So on Google Colab, you might have more than one CPUs as well. Okay, so now that we have a list of all the devices installed on our system, we can also specify TensorFlow to work with a specific device. But by default, TensorFlow automatically switches between the GPU and CPU depending upon the situation. So let me show you how you can specify TensorFlow to work with a specific device. So what you are going to do is you are going to type with, then tf.device, and inside this function you are going to type the name of the device that you want to use. Suppose if I wanted to use CPU 0, then I would write CPU 0 over here, but if I wanted to use GPU, then I will write the GPU along with the number or the GPU name that is specified over here. Okay, so if I type anything inside this with statement, it will be executed using the device that I have specified. Okay, so let's move on. Let me erase this. Now we are going to take a look at some stuff related to TensorFlow. So let's move on. Okay, so TensorFlow allows us to define operations and functions over tensors as computational graphs. So what do you mean by that? Well, let me show you using an example. So suppose that I had two variables, suppose a which is equals to 5 and b which is equals to 6. So what that statement means is that in TensorFlow most of the times we'll be working with graphs. All our operations will be represented in form of graphs. So suppose if I wanted to add these two numbers, I have to create a graph that explains how to do it. So I can create a node, and what this node does is it adds my two numbers. So now I can pass my tensors to this node, and this node will then compute the result based on the tensors that I have passed, and it will give me a result. So if I pass in a and b, it will give me the result 11. As you can see that this is a scalar, so any scalar in TensorFlow is called a rank 0 tensor. So this is a rank 0. So now you can also have vectors instead of scalars. So if I had something like this, then this would be called a rank 1 tensor. So this is rank 1 tensor. And now if I take it one step further, so suppose I have something like a matrix. So this kind of a tensor is known as a rank 2 tensor. Now I can also stack these matrix up and it would create a rank 3 tensor, and I can have as many dimensions as I want. So ranks are basically dimensions of your data, or the dimensions of your input tensors. Instead of a scalar, we can add a vector as well, or we can add a three-dimensional matrix. So it depends upon the input that you pass, and TensorFlow will automatically calculate the results for you if we are using the built-in functions that are available to us in TensorFlow. I'm not going to cover all of them, but if you want to know more about these functions, I will leave the link in the description below, and I will also leave a link to my Jupyter notebook in which I have created a list of the most useful ones that you will use commonly. Okay, so next we can convert our tensor into a NumPy array. So if I wanted to, I can convert my NumPy array into a tensor, or a tensor into a NumPy array. But by default, TensorFlow automatically does that. So suppose you are performing some function from the NumPy library and your input is a tensor, then it will automatically be converted to a NumPy array. And if you have a NumPy array and your operation is in TensorFlow, then it will automatically be converted into a tensor. So we will take a look at that later. For now, let's move on. So other than that, you can also perform some operations on your tensor, such as indexing or slicing, and you can also get some information out of your tensor, such as its dimensions, its data type, its shape, its axis, and its size. So other than that, there are some special types of tensors that you can create. For example, you can also create a ragged tensor. So if you don't know what a ragged tensor is, I'm going to create one and show it to you. So if I create a matrix, So suppose that this is my matrix, and if I wanted to create a ragged tensor, what I can do is I can say 1 2 3 4 over here, and then in the next row I can just put 2 elements instead of completing my row. So if I say 5 and 6, this would be a ragged tensor. So let me complete this. So keep that in mind that you can create ragged tensors in TensorFlow as well. So next you can also create a sparse tensor. So I'm going to create this again. So what is a sparse tensor? Well, a sparse tensor or a sparse matrix has some of its values that are empty, or it does not have any value in them. So if I say 1 over here and then 2 over here, then this would be called a sparse matrix. But if I didn't have this 2 over here or this 1 over here, what I mean by that is if I only had one of these values, it would still be called a sparse matrix. So a sparse matrix is anything that has empty spaces like this in it. So let's move on to Jupyter Notebook and look at everything that we have learned over here. So first let us look at how we can add two numbers. So if you wanted to add two numbers, you can use the function add. So I'm going to say tf.add, and then inside those parentheses I can enter any two numbers that I want to add. So I'm going to say 5, 6, and if I run this, it will return me the result, that is 11. So next you can also have vectors instead of scalars. So I'm going to say 5, 8, and then in the next one I'm going to say 6, 9, and if I run this, it will return me another vector, but that is the sum of these two vectors. So 5 plus 6 is 11 and 8 plus 9 is 17. You can also have three-dimensional vectors or three-dimensional arrays. So if I do something like this, and if I run this now, it will return me a three-dimensional array, and which is the sum of these two arrays. Next we are going to take a look at a function called square. So what square does is it squares out the number that you have entered or the vectors that you have entered. So if I say tf.square, then I can enter any number, for example 12, and if I run this, it will return me the result. So I can also add these two. So if I say tf.square 12 plus tf.square plus 12, and if I run this, it will return me the sum of these two squares. You can also have any other number, for example 15, and it will do the same thing for it. Okay, so next you can also add a list of numbers. So if you suppose you have a list and you wanted to add all the elements inside your list or your array, what you can do is you can say tf dot reduce sum, and inside there you can pass a array. So if I pass this, it will add all those numbers and return me the result, that is 28. Now I can also pass a vector as well instead of passing a 3D array, so that also gives me the same result. Next we are going to take a look at how we can do matrix multiplication. So I'm going to say tf.matmul, and next in the parentheses I need to enter a matrix. So I'm going to enter this. Now before doing matrix multiplication, you need to know that all the rules of matrix multiplication from mathematics apply. So the columns in this matrix must be equal to the rows in this matrix. So if I run this now, it will return me my result. So now let's look at how we can convert our Numpy array into a tensor. So to do that, I'm going to first import Numpy. So now if I create a Numpy array, so I'm going to say np.ones, and I'm going to create a 4x4 array. So this is my array. Now if I store it somewhere, so now my x variable contains the Numpy array. Now I can directly convert it into a tensor, or if I perform some kind of operation from TensorFlow, it will automatically convert this Numpy array into a tensor. So if I say tensor is equals to tf dot multiply, and inside there I can pass my variable x and the number that I want to multiply with. So I'm going to say 42, and if I run this now and look at my tensor, as you can see, it was converted into a tensor and multiplied with the number 42. Okay, so you can also convert this tensor back into a Numpy array. So I'm going to say np.array, and then if I pass my tensor over here, it will return me the Numpy array. Okay, so that was some basic stuff that we can do in TensorFlow. Now let's take a look at how we can get some information about our tensor. So if I write tensor and I wanted to know the data type of my tensor, so what I can do is I can say dot dtype, and that will return me the data type of my tensor. Now I can also get the shape of my tensor. So if I wanted to get shape, then I can just type shape over there, and if I run this now, it will return me the shape of my tensor. So other than that, I can also get the dimensions of my tensor. So if I type ndim, and if I run this now, and it will return me the dimensions of my tensor, that was 2D. So this tensor was 2-dimensional, so it returned me the dimensions equal to 2. So now if I wanted to find the size of my tensor, so what is the size of a tensor? Well, size of a tensor is all the elements that are present inside a tensor. So if I type tf.size, and inside there I can pass the name of my variable, so I'm going to say tensor, and if I run this now, it will return me the size, that is 16. Since my tensor was a 4x4 matrix, it had 16 elements in it. Okay, so next you can also index your tensor. So if I say tensor, and then I wanted to get this line, what I can do is I can say 0, and if I run this now, it returns me the first line. So this might not be clear in this example, so I'm going to take a different example. So I'm going to say my tensor is equals to tf.constant and then my array. So what this constant means is basically I'm creating a constant TensorFlow. So I'm providing my own values. So if you ever wanted to create a tensor and you wanted to enter your own values, you can just use this constant function. Okay, so if I run this now, and now if I wanted to get this array, what I can do is I can say my tensor, and inside there I can pass 0, and that will return me my first array that was present. Now I can go a step further, and I can also get the first array from over here, this one. So if I type 0 again, and run this, it will return me that array. Now I can also index a value from this tensor. So if I say another square bracket, and then if I wanted to get 2, I can just say 2 over here, and that will return me the value that was present at index 2. That was also 2. So next we can also perform slicing on it. So if I wanted to slice out my tensors, suppose if I wanted to get all these arrays and not this one, so I can what I can do is I can slice my tensor. So I'm going to say my tensor and then brackets, and I'm going to start slicing from the second one, so the second array. So if I do this and run this now, and it will return me the rest of my 2 arrays starting from over here. Okay, so the slicing is quite similar to the NumPy library, and if you know how to do slicing in NumPy or even in Python, then this should be easy. So if you wanted to slice further, what you can do is you can add another square bracket and then enter your index. So if I say 0 and stop at 1, and that will return me the second array that was over here. So this is quite easy and it's similar to Python. So let's move on, and next we are going to take a look at how we can create a ragged tensor. But before we do that, let me show you how you can create a variable in TensorFlow. So I'm going to say var x is equals to tf.variable, and then inside there I can just pass my tensor or the value that I want to create. Okay, so this v should be capital, and if I run this again, and this time it gives me no error. So if I say var x and run this, it returns me my tensor. So I can also give a name to my tensor. So to do that, I'm going to type name, which is equals to test. So if I run this now, so my name was changed to test. So this is quite useful when you are building neural networks, and we will look at it more when we get to it. So for now, just know how you can create variables inside a TensorFlow. Now this variable test is different from what we are doing over here or what we are doing over here. So these two are completely different things. So these names will be useful when we are actually working with neural networks and we want to like access a particular layer of neural nets or a particular neural net. So we will take a look at it later. So for now, let's take a look at how we can create a ragged tensor. So to create a ragged tensor, let us first create a ragged list. So I'm going to say ragged underscore list, which is equals to 1, 2, 3, 4, 5, 6, and then 7, and then 8 and 9. So now to create a ragged tensor from my ragged list, what I can do is I can say tf.ragged.constant, and inside there I can pass the name of my list. So ragged list, and if I run this now, it will return me my ragged tensor. Okay, so now we are going to look at how we can create a sparse tensor. So what I'm going to do is I'm going to say tf.sparse tensor, and inside this function there are several variables or there are several attributes that we need to pass. So the first one is called indices. So here you can pass the indices where you want to include your values. So for example, in the note over here, we had our values at 0 0 and 1 1. So I'm going to do the same thing in my tensor. So what I'm going to do is I'm going to say 0 0 and 1 1. So next we need to pass in the actual values that we want to include at those two indexes. So what I'm going to do is I'm going to say values is equals to my two values, that was 1 2. Now next we need to pass the shape of our tensor. So I'm going to say dense underscore shape is equals to the shape of my tensor. So the shape of my tensor was 3 cross 3. So 3 3. So now if I run this, it will return me my tensor that is a 3 cross 3 tensor, but it is a sparse tensor. That means it has some empty values in it. So this is how you can create a sparse tensor. So next we are going to take a look at how we can store strings in our tensor. So to create a tensor of string, so I'm going to say str underscore tensor is equals to tf dot constant. So the constant function is used when you want to create a tensor with a constant value. So if you want to enter your own values, you can use the constant function. So I'm going to enter a string over here, quick brown fox. So if I run this now and look at str tensor, and it will return me my tensor, and the data type this time is a string. So next we can perform some operations on our tensor, the string operations, and these will be quite similar to what we use in NumPy. So but the way that we use these functions will be different. So to perform some string operations, we need to first say tf dot strings dot if I wanted to perform any operation. So if you wanted to get the list of all the operations, you can press tab over here and it will return you all the values that you have or all the functions that are available to you. So I'm going to perform the split operation. So split, and inside there I can pass the name of my tensor, that is str tensor. So the next one will be how I want to split my string. So I want to split by this space, and so I'm going to put a space over here. So if I run this now, and it will return me my string that was split on the basis of a space. So you can also have more than one input. So if I say brackets over here, so I can enter a rank 1 matrix. So the second input will be hello world. So if I run this now and perform the split operation again, and it will split on the basis of space that I have specified, and it will be a ragged tensor because when we split this, the first array was of size 3 while the second one was of size 2. So this is where a ragged tensor might be useful, but there are many more uses of a ragged tensor as well. Okay, so suppose that we have numbers in our string and we want to convert that string into actually of type number. So first I'm going to create a tensor that has numbers in it. So I'm going to say num underscore tensor is equals to tf dot constant. Then inside there I'm going to pass a string that has numbers in it. So 1, 10 and 100. Now if I run this and try to print num tensor, and it has my string 1, 10 and 100. So now if I wanted to convert this string type into a integer or a floating point, what I can do is I can say tf dot strings dot to number. Okay, so now inside there, if I pass my num tensor, it will return me an error. Well, the reason is that because we have this space in there, this space is not any kind of number, so it will return an error. So unless I only have numbers in my string, I cannot use this function. So if I run this now, it will return me an error. So to fix this problem, what we can try is we can just split this string on the basis of the space. So if I say tf.strings.split inside that function, and instead of str tensor I say num tensor. Okay, so now if I run this, it will return me the numbers in form of a float. Okay, so now if I wanted the data type to be integer instead of floats, what I can do is I can put another comma, and after that I can say tf.int64. So if I run this now, it will return me integers instead of floating points. Okay, so that's it for today. If you have any questions, leave them in the comments below, and if you thought this video was helpful, you can like and subscribe, and if you want to be notified every time I drop a new video, you can turn on your notifications. Okay, I'll see you in the next tutorial.